Welcome to Learning from Home. This is going to be the first of a number of videos I'm going to be giving you guys to look through before you get into class. You should be pulling out your follow along notes, which you guys can see here. And today what we're going to be talking about is the mole. Before we get to the mole though, there's an overarching topic that we like to kind of be fancy with, and we call it stoichiometry. And although stoichiometry is a really fancy kind of snooty way of saying this, it really is simply chemistry math. And the all-star of stoichiometry is the mole. Now you may have heard of this before. Super fun fact, you know how we abbreviate like length has a unit for m, or other units get cut down? Mole, its unit is the mole. Literally, that's how we knock off this E, this blasted little E right here that for our unit. So the unit for mole is the mole. And when we think of a mole, we probably think about the creature. And this just horrified me. I had to put it in here because what the heck, man? I don't even think I think it has eyes there, but I can't be sure. Probably thought about moles before just as, stuff that we get on our skin. But the mole that we're going to talk about is actually a very specific number. And it's this guy right here. And that is an enormous number, which we're going to get to in just a bit. And I don't know about you guys, but I got tired just drawing this line. As you can see, I kind of petered out here at the end. So I don't want to be writing that out ever again. So what we can do instead is we can use exponents. Now, I'm going to save you the problem of counting up all the numbers going backwards, but we can instead write 6.02 times 10 to the 23rd. If you want more accuracy, you can write 6.022 times 10 to the 23rd. We will sometimes do that when we're dealing with more precise numbers. Now, just so you're aware, the mole is probably the most important number that we're going to deal with. And it also can seemingly be really confusing, but I want to demystify this because a mole is just a number, just like a dozen is just a number. Now, none of us struggles with the concept of a dozen. What is a dozen? Well, it's 12. 12 what? Well, 12 anything. I know that some of you guys are probably thinking in the back of your head, but what about a baker's dozen? And to you, I say, I am glad you were not able to speak in this video because I would have been very disappointed. But 12 is equal to a dozen. Similarly, a mole is 6.022 times 10 to the 23rd particles. Particles of what? Anything. So these particles could be cows or cookies, or I don't know, maybe atoms or molecules. Typically, we tend to use the mole, which is this incredibly large number, with really, really small things because we want to gather them up to be able to kind of account for them. But the reality is, just like a dozen is equal to 12, none of us has any issue with a dozen being equal to 12. A mole is equal to 6.022 times 10 to the 23rd. So if I said I had a mole of penguin, which seems like a lot of penguins to be quite honest, that would be 6.022 times 10 to the 23rd. Again, I've been drilled in with the 6.022. You can just write 6.02 times 10 to the 23rd. Which begs the question, well, how did they come up with 6.022 times 10 to the 23rd? I mean, I don't know. I didn't do any research prior to this about the dozen, but for some reason someone thought, you know what? Counting to 12, very, very difficult. Let's call it a dozen. And people are like, ooh, maybe it was Mr. Dozen who did it. I have no idea. But a mole, how did they come up with that number? Well, it's actually the number of atoms in exactly 12 grams of carbon-12. Now, I don't know if you remember way back when we were studying isotopes, but carbon-12 is a specific isotope of carbon that has 6 protons and 6 neutrons. So they took 12 grams of carbon-12 and they counted, we're not going to get into how they counted it right now. They counted all of the number of atoms in 12 grams of carbon-12. I don't know why I'm making little dots here. I guess that's me trying to count. And they came up with 6.022 times 10 to the 23rd, which begs the question, why 12 grams of carbon-12? They felt like it. They could have done 10 grams of tungsten, TT. They did not. They chose 12 grams of carbon-12. We're not going to go around that. All we're going to know is that 1 mole is equal to 6.022 times 10 to the 23rd. In fact, this number is so important, it's actually called Avogadro's number, in honor of Avogadro, oddly enough, right? Now, I want you to pause right now, maybe even pause the video, and I need you to memorize this. 1 mole is equal to 6.02 times 10 to the 23rd, or 6.022 if you're feeling kind of frisky. Pause, memorize it. Pound that into your head, because this is a conversion that we're going to be using over and over again. Now, before we go any farther here, in class we'll talk about this a little bit more, but I don't know if you have quite a grip as to how large this number is. So let's just say we took 6.02 or 1 mole times 10 to the 23rd watermelon seeds. They would essentially be found in a melon that's larger than the moon. Or if we, and this is my personal favorite, I had to include this in here, if we took 1 mole, or, you notice I'm doing this over and over again, 1 mole, which is equal to 6.02 times 10 to the 23rd donut holes, they would cover the earth up to 5 miles deep, the entire surface of the earth. Now, as much as a fat guy enjoys the idea of donut holes everywhere, I am pretty sure that would cause all life as we know it to end, so maybe that's too many. Pennies, if we took a mole of pennies, we could actually make 7 stacks going to the moon. Now, again, for those of you who are like, but wait, what about there being no gravity? It float away. Yeah, we get it. Theoretically, they're all glued together and somehow we made it out of our atmosphere. Never mind the logistics of doing that, right? Because the big concern is gravity taking it over, right? But 7 stacks that would reach the moon, that's pretty crazy. And then 1 mole, or 6.02 times 10 to the 23rd grains of sand, would be more than all the sands on all the sands. We Canadians call them sands. All the sand on Miami Beach, which if you've ever been to a beach, particularly Miami Beach, that's a lot of sand. Your takeaway, though, is simply this. 1 mole is just 6.022 times 10 to the 23rd of anything. Do not mystify this number up in any way. Now, how do we use the mole? Well, we're going to do some conversions back and forth. And I want you to fill this out because this is going to be kind of going with us. And our next videos, we're going to be working with how do we do calculations back and forth. But we've been talking about this right now. We like to go back and forth between particles and moles. But we can also go between moles and mass, which we measure in grams. I'll put that down here because it doesn't deserve top billing. We will be going back and forth using this kind of table throughout the next videos, but I'm glad to be back with you. Stay tuned. I will see you soon. Thanks.